Pressure measurement is used everywhere: pipelines, compressor, boilers, and hydraulic system. But what is the difference between pressure gauge and pressure transmitter? Let's understand it. Hello everyone, this is Raj from TechArt, your process automation strategist. In the previous module, we have learned about humidity and dew point measurement system. Now, we will move to another very important industrial parameter, and that is pressure. Pressure measurement is widely used across many industries. You will find pressure sensors in pipelines, boilers, compressors, hydraulic machines, and chemical processing plants. So, as an application sales engineer, understanding pressure measurement is very important for you because many industrial systems depend on a stable and safe pressure control. So now let's start with what is pressure. Let's understand pressure with a very simple example. Imagine you are sealing air into a bicycle tire using a pump. As you pump air, the air inside the tire becomes compressed. This compression creates pressure. If pressure becomes too high, the tire may be burst. If pressure is too low, the tire will not function properly. So, pressure must be monitored and controlled. The same concept applies to industrial system. Pressure tells us how much force fluid or gas is exerting inside a system. Now, pressure can be measured in different units. Some common units are bar, psi, pascal, millibar, kilogram per centimeter square. For example, 1 bar is approximately equal to 14.5 psi. In industrial instruments, pressure ranges very low pressure like 10 millibar to very high pressures like 1000 bar. The most basic pressure measuring device is the pressure gauge. A pressure gauge usually has a mechanical dial display. It shows the pressure value using a pointer and a scale. Pressure gauges do not require electrical power. They are commonly used for local pressure indication. You will often see pressure gauges installed on boilers, pipelines, air compressors, or hydraulic machines. Operators can quickly look at the gauge and check if the pressure is within the safe range or not. Sometimes, pressure must not be only displayed locally but also sent to control system. For example, PLC or SCADA systems, control panels. In such cases, we use pressure transmitter. A pressure transmitter converts the measured pressure into a standard industrial signal. Here, most common outputs include 4 to 20 mA, 0 to 10 volt, and Modbus communication. This signal can then be transmitted to a control system for monitoring and control. Pressure transmitters are widely used in automation system. Another important pressure instrument is the differential pressure transmitter, often called as a DP transmitter. A DP transmitter measures the difference between two pressure points. For example, pressure at a pipe inlet, pressure at pipe outlet. The difference between this pressure can tell us useful information. DP transmitters are commonly used for flow measurement, filter monitoring, and level measurement in tanks. If a filter becomes clogged, pressure drop across the filter increases. A DP transmitter can detect this change. Now, let's understand an important concept: gauge pressure versus absolute pressure. Gauge pressure is the pressure measured relative to atmospheric pressure. This is the most common type of pressure measurement used in the industry. For example, if pressure gauge reads 5 bar, it means the pressure is 5 bar above atmospheric pressure. Absolute pressure, on the other hand, measures pressure relative to the perfect vacuum. Absolute pressure is often used in applications like vacuum system, scientific processes, and altitude measurement. Now, as an application engineer, it is important to confirm whether the customer needs gauge pressure or absolute pressure. Now, selecting the correct pressure range is very important. If the selected range is too low, the instrument may get damaged. If the range is too high, measurement accuracy may decrease. A common rule is the normal operating pressure should be around 60 to 70% of the instrument range. For example, if the system normally operates at 6 bar, selecting a 0 to 10 bar transmitter would be suitable. Proper range selection ensures both safety and accuracy. Another important factor when selecting pressure instruments is the process connection. This refers to how the instrument is physically connected to the pipeline or system. Common process connections include 1/4-inch BSP, 1/2-inch BSP, NPT threads or flange connection. The correct connection must match the customer's piping system. Sometimes special accessories are also used, such as pressure snubbers, siphons, and isolation valves. These accessories help protect the instruments and improve measurement reliability. Now let us take a real industrial example. A customer says, I want to measure pressure in a compressed air pipeline. Now, as an application engineer, you should ask, what is the pressure range? What type of output is required? Where will the instrument be installed? What process connection is needed? Based on this information, you might suggest 0 to 10 bar pressure transmitter with 4 to 20 mA output with 1/4-inch BSP process connection. This is how application-based instrument selection works. In this module, we have learned what pressure measurement is, types of pressure instruments, pressure gauges, pressure transmitters, differential pressure transmitters, and we also discussed gauge pressure versus absolute pressure, pressure range selection, and process connections. Pressure instruments plays a very important role in industries such as chemical plants, oil and gas, water treatment, compressed air system, and hydraulic machinery. Understanding pressure measurement system will help application engineers recommend the correct instrument for each application. In the next module, we will learn about level measurement system, which are widely used for measuring liquid levels in tanks and storage vessels. Thank you so much for watching. See you all in my next video.